Imagine a world where a new home can rise from the ground in a single day. A world where the lengthy, costly, and often messy process of construction is transformed into something swift, elegant, and precise. This isn't a scene from a distant science fiction film. This is a reality taking shape right now. A remarkable new robot, a marvel of modern engineering, is promising to do just that. It can build the walls of a sturdy, habitable structure in less than 24 hours. The very notion challenges our centuries-old understanding of what it takes to create a home, turning a painstaking craft into an act of incredible speed and efficiency. This is more than just a new tool. It is a complete reimagining of architecture itself. This incredible machine was developed by a team of brilliant engineers and visionary architects. They saw a fundamental problem in our world, a desperate need for affordable housing and a building industry that struggles to keep pace. Their solution was to look to nature for inspiration, combined with the cutting-edge power of robotics. The result is a machine that looks uncannily like a giant mechanical spider. Its long, articulated legs give it stability on uneven terrain, allowing it to navigate a building site with a surprising grace. This design isn't just for show, it is a masterclass in functional form, enabling the robot to work methodically and without interruption. So, why a spider? The answer lies in its ability to move with precision in 3 dimensions. Traditional building machinery is often clunky and limited to linear movements. This robotic arachnid, however, can reach over and around the structure it is creating, much like a weaver spinning its web. Its multiple legs anchor it securely, providing a stable platform from which its building arm can operate. This allows for the creation of complex, curved walls and organic shapes that would be incredibly difficult and expensive to produce using conventional brick-and-mortar methods. The design is a triumph of biomimicry, learning from the efficient elegance of the natural world. The promise of building a house in a day is truly revolutionary. Think of the implications for disaster relief, where shelter is needed immediately after a hurricane or an earthquake. Consider the millions of people worldwide living in inadequate housing, waiting for a solution that is both fast and affordable. This technology could provide a lifeline, offering dignity and security in a fraction of the time we ever thought possible. It represents a monumental shift, a moment where the slow, deliberate art of building meets the exponential speed of technological progress. The 24-hour home is no longer a dream. It is standing on the horizon, ready to be built. The magic of this process lies not just in the robot, but in the very materials it uses. Instead of concrete blocks or fired bricks, this machine builds with the earth itself. It uses a mixture primarily composed of local dirt, sand, and a special binding agent. This raw material is mixed on-site, creating a kind of high-tech mud that is both incredibly strong and wonderfully sustainable. The robot's nozzle carefully extrudes this mixture layer by layer, building up the walls from the ground up. This method, known as additive manufacturing or 3-dimensional printing, is precise, efficient, and produces almost no waste whatsoever, a stark contrast to a typical construction site. This approach is profoundly different from traditional building. Conventional construction is a subtractive and often wasteful process. Materials are shipped from far away, cut to size, and the offcuts are discarded. This robot does the opposite. It is an additive process, using only what is necessary to form the structure. There are no piles of rubble, no discarded packaging, and no need to transport heavy bricks across continents. The carbon footprint is dramatically reduced. By using soil found directly at the building site, we are returning to a vernacular architecture, a way of building that is in harmony with its local environment, but now supercharged with 21st century technology. The environmental benefits are simply staggering. The cement industry alone is one of the largest producers of carbon dioxide in the world. by largely eliminating its use. This robotic construction method offers a path toward a greener, more sustainable form of architecture. It allows us to build without plundering the planet's resources or polluting its atmosphere. The finished structures are also naturally insulating. They're thick, earthen walls, keeping the interior cool in the summer and warm in the winter. This reduces the home's energy consumption for its entire lifespan, creating a building that is not just green to build, but green to live in. And the ambition doesn't stop at our own planet. The principles behind this technology are being seriously considered for building habitats in the most extreme environment imaginable, the moon. Astronauts cannot take a lorry full of bricks with them into space. But the lunar surface is covered in regolith, a fine, powdery soil. A robot like this could be sent to the moon to use that very regolith to print shelters for future astronauts. It could create a base camp before humans even arrive, using local materials to protect them from the harsh radiation and extreme temperatures of space. It's a grand vision, turning lunar dust into the foundations of a new human outpost. Before we see these spider bots building entire suburbs, there are significant challenges to overcome. This is, after all, a pioneering technology. The first hurdle is durability and long-term testing. How do these earthen walls stand up to decades of wind, rain, and changing seasons? We need to conduct rigorous tests in a variety of climates, from the freezing cold of the north to the humid tropics. We must be absolutely certain that these 24-hour homes can last for generations. Safety and structural integrity are paramount, and there is no room for error when you are creating the places where people live their lives. Then there is the matter of building codes and regulations. Our current construction laws are written for homes made of wood, brick, and concrete. They don't have categories for three-dimensional printed earthen structures. Planners, councils, and safety inspectors will need to understand this new technology and develop standards to ensure every home is safe, secure, and insurable. This bureaucratic process can be just as complex as the engineering itself. It requires collaboration between innovators, governments, and the construction industry to create a new blueprint for how we approve and certify these revolutionary buildings for public use. We also have to consider the rest of the house. This robot is a master at building walls, but a home is much more than its shell. It needs plumbing, electricity, windows, doors, and a roof. The current process still requires human tradespeople to come in and install these essential services after the robot has finished its work. The next great challenge is to integrate these tasks into the robotic process. Can future versions of the robot be equipped to lay pipes and conduits as it builds the walls? Can it leave perfectly sized openings for window fitters? Creating a seamless workflow between the robotic and human elements is crucial for true efficiency. Finally, there is the human element. The construction industry employs millions of people worldwide. The rise of automation will inevitably change the nature of this work. While some jobs may be replaced, new ones will certainly be created. We will need robot technicians, material scientists, digital designers, and site managers who are trained to oversee these automated building projects. The transition will require a focus on retraining and education, ensuring that the human workforce can evolve alongside the technology. The goal is not to replace people, but to empower them with incredible new tools to build better and faster than ever before. Despite the hurdles, the potential of this technology is undeniably exciting. We are standing on the cusp of a construction revolution, a fundamental change in how we create the spaces we inhabit. For too long, building has been a slow, expensive, and labor-intensive process, putting home ownership out of reach for many. Robotic construction offers a future where decent, well-designed homes can be built quickly and affordably. This is not about creating soulless, identical boxes. On the contrary, this technology allows for architectural creativity, enabling the design of beautiful curved and organic forms that are tailored to their environment. This innovation could be a powerful tool in tackling the global housing crisis. In rapidly growing cities and developing nations, the demand for housing far outstrips the supply. Imagine fleets of these robots being deployed to build entire communities in a matter of months, not decades. They could provide safe, permanent homes for people displaced by conflict or climate change, offering stability and hope where it is needed most. This isn't just about building houses, it is about building communities and fostering social progress on a massive scale, using technology for the betterment of humanity. The shift toward robotic building represents a more intelligent and respectful way of making our world. It forces us to think about materials, waste, and our impact on the environment. By using what is locally available and designing with digital precision, we can create a building culture that is sustainable and regenerative. It connects the most ancient of building materials, the earth beneath our feet, with the most advanced of our tools. It is a beautiful synthesis of the old and the new, a digital craftsmanship that is both efficient and deeply connected to its place. This is the kind of thoughtful innovation that architecture has been waiting for. In the end, a house is more than just a structure. It is the foundation of a life. It is a place of shelter, security, and dreams. The ability to create these essential spaces with greater speed, less cost, and more care for our planet is a truly profound achievement. The spider-like robot patiently weaving walls from soil and sand is not just building a house in a day. It is laying the foundations for a new future, one where good design and a safe home are accessible to everyone. The project of building is never truly finished, but with tools like this, we can begin to build a better world, one home at a time.